Hello and a very good day for everyone. Today, our group will present about the first order differential equation (ODE). This topic is in the last chapter in engineering math in this sem. So, who is my team? We have Ahmad Fayed, we have Amir Fitri, and we have Hamdi.
Assalamualaikum. My name is Muhammad Amir Fitri. My matrix number is AA221478. I will talk about the introduction of first order ordinary differential equation. Mathematics play a crucial role in estimating death time and predicting the bacterial growth. For forensic science, mathematical models like Newton's law of cooling help determine the time of death. In biotechnology, first order differential equations are used to forecast the bacterial growth trends, aiding in environmental science and industrial application. For the problem statement in this chapter is looking forward into the application of first order ordinary differential equation or ODE. These are the application in and time of death using Newton's law of cooling and the bacterial growth.
Hello and Assalamualaikum everyone. My name is Ahmad Fahid bin Swadazima and my metric number is 230600. And today I'm going to present to you guys Fila Table Part A. Firstly, we have five main facts. First one is the detective finds the victim at 9 a.m. And second one, the room temperature is at constant of 20 degrees Celsius. And the initial body temperature measured at 32 Celsius. Body temperature cools to 30 Celsius 2 hours later, which is 11 a.m. And lastly, we have the victim's body temperature when the murder occurred is assumed to be 37 degrees Celsius. And next we move on to the ideas. There are also 5 main ideas on this Fila table. First one, we can use Newton's law of cooling to estimate time of death. We can establish the relationship between the body temperature and time. And thirdly, we can apply the formula. And fourth one, we can determine the time when the body temperature was at 37 degrees Celsius, which is the time of death. And lastly, we can utilize initial and ambient temperatures along with the measures cooling to find the constant cooling with a cooling constant K. And we have also 5 main goals from this project. First, we can understand how to apply Newton's law of cooling in forensic science. Second, we can learn to derive and solve first order differential equations related to temperature changes. We can gain skill in using mathematical models to solve real-world problems. Fourth, we can develop the ability to interpret and analyze temperature data to predict the time of death. And lastly, we can improve problem-solving techniques using differential equation. And lastly, we can have action. First action is that we can calculate the cooling constant K using given temperatures and time intervals. Use the calculated cooling constant, which is K, to determine the time elapsed since the murder. We can back calculate from 9 a.m. to find the exact time of death. We can verify calculation and ensure the results are logical and consistent with the given data. And lastly, we can present findings in a clear and concise manner, explaining each step of the calculation process.
So we will explain about Fila table part B. So what is the fact of this question? So we will see the growth and decay is given by the formula P equal to principal time equal to principal in the power of exponent K for the constant and time also. And what is the idea for this for the part B question 1? So it can calculate the amount of cell after 1 day of growth if this unlimited growth continues. So this we can learn about the calculation and create the formula of growth and decay. And what is the action? The action is we can research the formula and learn how to do the calculation. We move to the second fact for the question 2. It is the doubling time of bacteria is equal to n. N is our principal also. Principal T time equal to 3n. Because of what? Because we need to know what is the triplet of the bacteria in 3 hours. No, we need to know what is the time of triplet bacteria. So what is the ideas of this? So, like I say just now, the idea is find the template time of the bacterial growth. So we can understand how to use the formula to calculate the time growth of bacteria. So what will we do in this question? We will use the formula to find the growth versus time.
Hello and Assalamualaikum. For part A, the question is a detective finds a murder victim at 9 a.m. in a room that is kept at a constant temperature 20 Celsius. The temperature of the body is measured to be 32 Celsius. 2 hours later, the temperature of the body cools to 30 Celsius. Assuming that the temperature of the victim when the murder occurred is 37 degrees Celsius, at what time the murder occurred? Okay, from the question we can get that the murder, the victim, detective finds the victim at 9 a.m. So finds at 9 a.m. at a room that is kept at 20 Celsius. So T surrounding of temperature surrounding is 20 Celsius. The temperature body is measured. This is at the 9 a.m. is 32 Celsius. And after 2 hours later, the temperature of the body cools to 30 degrees Celsius. Assuming that the body temperature of the victim when the murder occurred is 37 degrees Celsius. So the murder occurred at at certain time, the degree of the body is 37 degrees Celsius. So we must find the approximate time that the murder occurred. Okay, next. Okay, from the question, we can get that T surrounding Ts is equal to 20 degrees Celsius. T initial T naught is equal to 37 degrees Celsius. Okay, from the question we can get that the temperature initial or temperature 1, we can call it as T0 because it is at 9 a.m. The body found is 32 degrees Celsius, and T2 it is when 11 time at 11 after 2 hours. So T2 is equal to T plus 2 equal to 30 degrees Celsius. So formula that we can use is the Newton formula of temperature. T temperature equal to T surrounding plus in the bracket T naught minus T surrounding E to the power of negative KT. K is constant, T is our time. So from the formula, you can get that T0 is equal to 20 plus 37 minus 20 in bracket E to the power of EKT, negative KT. So we just substitute the nilai, the value to the formula. We can get that 32 minus 20 equal to 17 E to the power of to the power of negative KT. So we just simplify the formula. So it will get that 12 over 17 is equal to E for the power of negative KT. So we just log both sides. We can get that ln 12 over 17 equal to negative KT. Okay, that is our first equation. So for the next equation, we can get that T2. Our T2 is 30 degrees Celsius after 2 hours equal to 20 plus 37 minus 20 in bracket to E times E to the power of negative KT. So you just substitute the formula, the value to our formula. So we can get that 30 minus 20 equal to 17E to the power of negative KT. Simplify just like the first formula. We can get that ln 10 over 17 is equal to negative KT. Okay, that is our next equation. So we can know that since T2 is equal to temperature 2 is equal to time plus 2. To explain that, the time the body found is at we don't know. The time the body found is 9, but the time that the murder occur we don't know. So we just using the formula that we use, we can simplify it to T2 is equal to T plus 2. Okay? Okay, we just okay, next. We can get that ln 10 over 17 is equal to negative K in bracket T plus 2. So we just open the bracket and simplify it further. So ln 10 over 17 is equal to negative KT negative 2K. Okay, that is our third equation. Okay, next is very simple. Just substitute the first formula to the third formula. So ln 10 over 17 equal to ln 12 over 17 minus 2K. Okay, we can get that negative KT at our second equation. Okay, so we just simplify the equation to get our K value. So K is equal to 0.0912. Okay, that is our K. K is constant, okay? Ln 12 over 17 is equal to negative 0.0912 T. So you can get the time is equal to 3.82 hours. So the 3.82 hours we can get convert it to minutes is equal to 49 minutes. So we can get that 3 hours and 49 minutes before 9. So we just minus the time 9 a.m. in the morning minus 3 for 9 is equal to 5:11 a.m. So the answer for this question is the time of death is approximately at 5:11 a.m. Okay, thank you.
So we see the question of part B. In a particular culture, the rate of increase of bacteria is proportional to the number of bacteria, P. So when I said the number of bacteria is P is equal to principle. Yeah, the number of bacteria is principle, present at time T, hours after the experiment. Given that the number of bacteria at the beginning is 10 power of 6 and after 1 hour is 10 power of 9. So find question 1, the number of bacteria after 5 hours. So we see here we want to know the principle after 5 hours. So the second question is the time taken for the number of bacteria to be 3 times the original. So this is what I say. We will use the formula and the principle also T equal to 3m because we want to see what is the time after we triplet the bacteria.
For the solution of part B, the question is to find the numbers of bacteria in 5 hours. The reason is we use dP over dt equal to Kp. And after we simplify the formula, we get the P equal to AE power of Kt. Firstly, we must find the constant K. So we use the 10 power of 0 as our initial P and 10 power of 6 as our A. After we calculate it, we get e power of k equal to 10 power of 3. And then we simplify and we get that k equal to 3 ln 10. And then we search the number of bacteria in 5 hours. So P5 equal to e over 3 ln 10 multiple with 5. And then we get the answer is 10 power of 40. For the next question B, is the time taken for the numbers of bacteria to be 3 times the original. Firstly, we know that the time taken is 3 times of the original time. So 3p initial equal to p initial multiplied with e power of 3 ln multiplied with t. So the answer we get after we simplify it is ln 3 equal to ln 3 multiplied with t. After that, we move 3 ln 10 to the other side with ln 3 and we get ln 3 over 3 ln 10 and we solve it and the final answer is for t is 0.159 hours.
In conclusion, this chapter investigates the application of first order ordinary differential equations, also known as ODE, to estimate the time of death using Newton's law of cooling and to predict bacterial growth. These mathematical techniques provide precise predictions and valuable insights for forensic science and biotechnology. Newton's laws of cooling helps determine the time of death by modeling body temperature changes, while ODEs are essential for forecasting bacterial growth trends, which are crucial for environmental science and industrial applications. This demonstrates the significant role of ODEs play in addressing real-world problems across various scientific disciplines. So I guess that's all from our group. Thank you.
So this is from 4 of us about the ODE. Thank you.